Okay, we're going to take a moment to discuss congruence theorems. Okay, and these always get people a little flustered just because they're so wordy. There's a lot of words to them. Now, if you think logically about what they represent, visually this is going to be very easy to walk through. Okay, now what we're getting at is if you see two random triangles in any drawing, can you tell if they're exactly the same? Or in other words, can you tell if they're congruent? Meaning all their angles are the same and all their sides are the same. Now you could get out a protractor and a ruler and start measuring and try to figure it out that way. Or if you know these congruence theorems, you can find out the shortcuts. Okay? If I know just a couple pieces of information, I can figure this whole thing out and I can know whether or not they are congruent. Now there's a whole bunch of these and we're not going to take the time to go through every single one of them in this. That's what you're going to be doing in your class. But I'll just list a couple of the popular ones. You have one called SSS, side, side, side. Okay? And all that means is if each one of these triangles has a congruent side or a side that's equal on the other triangle, and you'll work all the way around the triangle so it has three sets of equal sides, then we know the triangle has to be exactly the same. Its angles have to be exactly the same or it wouldn't connect. Side, side, side means I have three congruent sets of sides. Okay, you also have something like this, SAS, side, angle, side. Okay, if I have two sets of congruent sides and the angle between them is the same, then the rest of the triangles have to be the same also. Okay, you also have one called angle, side, angle, okay, which means if I happen to have two congruent angles and the side in the middle of them is the same as on another triangle, then they have to be congruent also. So what you're really looking for is, can I use one of these theorems? And there's other ones, and you'll work through all these in class. I just want you to see an example of it. What we want to do is we want to look at these two triangles I've drawn and just see if we can figure out, okay, what we're looking at. Like what do we know that is congruent? Okay. Now when I look at this side right here that has a little red dash on it, I look over here, I see another red dash. What's that little red dash mean? It means this side right here is exactly the same length as this side. So I have one congruent side. Okay. Now I also have a drawing that shows these two little dashed blue lines. Okay. And what that means is this side over here is the exact same measurement as this side. So I've got two congruent sides. Now do I have a third congruent side that is definitely measured and shown? No, there's nothing telling me that this side right here is exactly the same as this side. But geometry is about finding things that we can figure out without having to go through all the math of it, okay, logic. So I'm not shown that those two sides are the same. So what I have here is I have two sets of congruent sides, okay? So I know I can't be, this theorem right here won't definitely prove the triangle at the moment, the triangles at the moment. But what about this one? SAS. Do I have a side, another side? Yes, I've seen that. What about the angle in between them? Well, here I've got a right angle, another right angle. So I know those are the same. So I have a side, an angle, and a side. Side, an angle, and a side. Okay? So this theorem, SAS, will prove that these two triangles are completely congruent. Okay, what it means is I could walk through a bunch of steps and eventually see that this angle and this angle over here have to be the same, and this angle and this angle are going to have to be the same, and then this side and this side are going to be the same. But rather than going through that, once I know two sides and the angle in between them, this theorem says that's enough to tell me those triangles are exactly the same. So I don't need to worry about any of the other ones. And what you're working on in this section is just exploring those. Okay, looking at different drawings and saying which one of these theorems may prove that I've got two identical triangles. Okay, and which ones, in this case, don't happen to prove that.